Hey guys, on episode 3 of the antenna building series, we're going to build a trapped dipole. So let's go outside. I'm going to show you one of the main reasons why. All right, we're outside here next to the antenna mast. And I don't know if you guys can see this or not, but what has happened is the supports have got caught in the wind and have spun around and twisted everything all up. And this has happened 2 or 3 times. So what I want to do is I want to get rid of the fan dipole and I want to put up a trapped dipole to get multiple bands with no tuner and kind of solve that issue. So let's go back inside and build this thing. All right, guys. In order to fix this problem, we're going to build a trapped dipole. So the first thing I want to do is take down the fan dipole so I can reuse the elements on that. Then I'm going to kind of educate a brief overview of traps. I don't want this to be an engineering course by any means. Then I'll show you how to build a trap, and then we will test a trap. We can use like a nano VNA or just a SWR meter. You could potentially even use your radio if you have an SWR meter in there. So I'll show you a little technique on how to do that. And then we will put it all together, get the antenna strung out, get it up in the air, tune it. It's probably gonna take a few extra steps to tune just because the lengths are gonna be a little bit wonky with the inductance introduced through the coil. We'll talk about that. So come check this out. All right, this is just going to be a quick trap overview. I don't want to make a huge course out of it, just basic stuff to get you through this build. So what is a trap? A trap is an inductor and a capacitor in parallel. It creates a tuned circuit. The frequency is there, and that frequency is in hertz, henries, and farads. So you have to do the conversion on that too. But there's a cool tool that we can use to do that for us. So at k7mem.com, there's a really good website sitting here. So it talks a lot about trapped antennas. I'll scroll down. You guys can go to this on your own, but I want to show you the tool at the bottom of the website that will help us design the one that we're building. So here's the tool, and if we're going to use RG316, so we're going to change this drop-down box. And then we want our frequency to be 50 megahertz. And then we're going to be using a 1/2 inch PVC. Does all the math for us, the magic of computers. Shows us our resonant frequency, our capacitance that we're going to need, our inductance, and the effective length. This will be important when we start to measure out our antenna. All right, now that you are all educated up on traps and how they work, we're going to go ahead and build some. So I took the liberty of building a few to get started. I've got a pair for 6 meters. I've got a pair it would work on 10 or 12, just like we talked about. It'll be an open, so they actually tuned in for 12, but I can use them for 10. We'll put 10 up on this antenna just in the spirit of technicians getting on HF, so we'll use 10. And then I've got one 20 meter built, and we are going to build the last 20 meters. And then I have the materials also for 40 meters, so for a 40 meter trap. So my plan is to put this thing out. I'll go out to 40 with it, go 6, 10, 20, 40. It'll terminate at the end at 40. If I feel like I have enough room because it's short enough to put 80 on there, I'll build some 40 meter traps and run 80 out, or potentially 60. So that's kind of the plan on that. So let's get to it. So what I found is the outside diameter of the pipe that I'm using is a little bit less than the calculator, so I got to put a little bit more than what the calculator says. That's kind of just what I figured out by do with the rest of these. But basically what I do is I try to drill the hole close enough to where I can get the screw through, get these started. Alright, to make it a little easier, is what I do is I just put a little bit of a bend on the end of this just to kind of give me enough to play with, and then put my wraps on. So I need 7 in this instance. So that's 1, 2, 6, and 7. So I count them from here. 1, 2, 3, 4, 5, 6, 7. So I want to make sure I have a little extra. Alright, so first thing I'm going to do after I got my length is I'm going to just unwind it. And it makes it a little easier to work with, and then I'll get this end prepped, the input side, and I'll wrap it, put a little tape on there to hold it, get the outside done, and then cross them over and put them together. So what we're going to do is we're going to trim off the outer jacket so that we can get the just kind of want to show you this trick here. So one of the easiest ways I have found, instead of trying to work this back, is to try to get a little hole built right at the bottom. So you can see that. If you see that, you got kind of a loop there, and then you can just pull the center conductor out. And then I kind of just get this all twisted back together. And there you have it. Kind of a nice trick. And for the center conductor, I want to strip the coating off of that. Alright, so now we got this prepped, and what I'll do is I'll wrap the center conductor around the screw and make a little bit of a loop, and that should make it work just great. Alright, so I got this one on here, and then what you're going to want to do is have yourself a piece of tape ready, because once you start wrapping this, you can put that piece of tape on there to hold it before you start doing the other side, because it's a little bit kind of coily and springy, so it tries to unwind, but you want to be able to hold it there so you can work. So we need 7 wraps. We got 1, 2, 3, 4, 5, 6, 7. So that's what I'm going to do. I got this tight, and kind of twist it down a little bit, just get it as tight as I possibly can. And I'm going to get my piece of tape, try to hold everything together, and just put a wrap or 2 on it just to kind of hold it in place while you're working on it. Try to keep that coil nice and tight. Okay, so now what we've got is we've got our little pigtail end. We're going to come back and go from the center conductor. So the center conductor will come out and come over to our shield on the other side, creating that second loop through there. And then our shield on this side will go around the out. And then when we get our wires, they'll go onto these and put this into series with our wires. So let's do that. All right, so there, I just have this in here, and then this kind of crossed over and wrapped together. So I'm gonna just put a little bit of solder on this to keep that connection great, and then we'll wrap it with some tape, and we'll go get it test it, I'll show you guys how to set up an SWR meter to test these to see where they're going to be trapping at. Trick to the tape is to just keep it mechanically sound, so as if this coil can move, your inductance and your capacitance will change, and therefore will change where it's trapping at. So you want to make sure that none of that can really move. And then once everything's hooked up, you can weatherproof it a little bit more if you want, once all your other connections and stuff are hooked up. So there you have it. Let's go test it. All right, so this is the testing setup. So you'll see here's the trap we're gonna test. I've got a nano VNA. Now this will work with just an SWR meter. You're just reading the SWR of where it's resonant, and that will be the trap frequency. So all this is just a little coax cable around to just a split, and then I've built a little wire loop. And then all I have to do is loosely couple this with the trap, and you will see that it dips, and I've got it pulled up here. Hopefully that's a little easier to tell. It's like 13.8. So if you remember from earlier, anything above that frequency, it's going to show as an open. So at 14 megahertz and higher, where we're going to have our 20 meter band tuned, it will show an open. So that'll be the end of the antenna at that point, accordingly, electrically. So hopefully that helps, and drop some comments if you need to get some clarification on that. All right, so what we're going to do is we're going to reuse our mounting point for the fan dipole, but we'll just have one element coming off there. So we need to make elements for 6. 6 is going to be the same as it normally would. There's no trap before it. And then we'll go to 10, which will be the 6 meter plus the effective length of the trap, plus some extra wire to get it to 10 meters. Then we will do our 20 with the same process. So we'll have chunks of wires all in series with the traps, and then out, and then we'll get it hung up, test it, go make our adjustments as we need to, and eventually we're gonna have a multiband antenna. All right, so what we're gonna do is we're gonna use the Ham Radio Toolbox app that I made and published to get our antenna length. So check this thing out, antenna calculator, then we're gonna punch in 51 megahertz, and it's gonna tell us how long we need to cut this thing. So the 4.82 feet is gonna be each leg of the dipole. So while we're in here, we might as well figure out our other frequencies too. So if 28.5, hit submit, it'll show us that we need 8.63. So what we're going to do is we're also going to take off the effective length of that coil from the other calculator that we use too. So that'll help us get a little bit narrowed in. But we're going to kind of overcompensate here too. So we'll make it a little bit longer, then tune it down. And then 14.2, 17.3. So the other little cool thing you can do on this is the tuning calculator. If you put in your target frequency that in your original length that you cut it for, and once you get it up to where it needs to be, and it shows where, and you tune it and you measure it for like say 48, and you hit submit, it'll tell you how much to take off. So that kind of helps speed that process up a little bit too. So go check it out. So that app definitely makes it easy. I'll put a link in the description. Now that we have our length of wire, we'll just hook that up to this, to our mounting bracket that we'll have, and we'll hang this up. As what I'll do is I'll build this antenna, and then I'll show you the kind of finished product. Then we'll get it hung up, and I'll show you spend more time on the tuning process of it this time, so you guys can kind of see that and learn a little bit more that way too. I'll put the link to the app in the description, so you guys can check that out too. Okay, we got it complete. So we got our middle piece, and then we run out along here. We got our 6-meter trap ready to go, our 10-meter trap ready to go, our 20 meters, and then we just got the rest of the wire measured out to do 40. So then the opposite side is the same thing, just goes the other direction. So the next step is to get up on the ladder and get this thing hung up. So we'll get that hung up over there and start the tuning process. Okay, so what we've got here is we've got our cable coming in from our antenna into our adapter to the Nano VNA, and we've got Nano VNA saver up, okay, and then I actually have it blowed up here too. So you can see that. I just want to show you guys the setup. So I've scanned the whole band and it looks like we're long. That's how we kind of overcompensated to make sure it was long. So now I'm going to go through and I'm going to start with the 6-meter. I'll come over here, you can see it a little bit better, and I'll put something up on the screen probably, but you can see we're a little long, so I'll go out and I'll trim that down to where I can get that where I want it. All right, time to go test again. All right, here's the very first scan, and then I zoom in on 50 meters here, and then you can kind of see where that is. So then I go outside and I cut a little bit, trim it, and then come back in and scan it, see how much it adjusts, and then kind of keeps cutting and scanning until I get it kind of tuned in. This is probably the second or third to last one I did. I got it kind of tuned in good. All right, guys, got the final tune down. I'm ready to just put it back up in its final place. Just figured I'd come out and show you kind of what everything looks like a little bit closer. And this is what I'm going to do is I'm just going to wrap this up with the black electrical tape too, and I'll show you guys that too in a second. And then it's just a matter of getting the hole and everything back up in place, and then we'll go get on the air. All right, so just going to show you this real quick. All I did is just tape this, put a bunch of tape around it, and kind of did that for each one of them. So now I just need to make sure I get everything back up where it needs to be, and we'll go get on the air. So come with me. All right, well, now we're back on the radio, so let's see if we can't call CQ and get somebody. KJ7IAZ, is this frequency in use? QCQ, this is Kilo Juliet 7 India Alpha Zulu calling CQ and listening. Alright, old man, I got you real weak in there. Go again with your full call sign 2 or 3 times and let me see if I can't pick you out. I think I got you that time. I got Kilo 4 November, Juliet November, QSL.
QSL 5151 South Carolina. Your call again?
Roger, the 5-1. You're about a 5-5 now. You kind of came up. My call again is Kilo Juliet 7 India Alpha Zulu, and I'm up here just testing a new 10-meter antenna that I just built.
Roger, Kilowatt Juliet 7 India Alpha Zulu, Kilo 4 November, Juliet November, 5555 South Carolina. What state are you located in? Over.
Yeah, I'm up in Montana, Mike Tango. All right, so there you have it. We're on the air. We got a contact on 10 meters and all on an antenna that we built ourselves. So we should feel very accomplished for that. So I hope that inspires you to go out and build your own antenna and start getting on the air that way too. So thanks for watching 73s, and if you haven't done so already, make sure you subscribe to this channel so you can continue getting the future antenna builds that we get. And other than that, thank you again.